As an information technology professional, you'll find that there are several methods that you might use to determine how many subnetworks you need to create in your network. It might be from viewing a Visio diagram, or instructions from a superior, or your own knowledge of the network that requires subnetting. In the CIS Tutor subnetting assessment, determining how many subnets you need to create is quite easy. Just count the number of lines extending from the image of the router. Each of those lines represents a segment, or subnetwork, that needs to be created in the current assessment you're working on. Just count the number of lines and then type that number in the box at the top right of the screen. Once you see the green correct appear, then click on the button at the bottom right of the screen that says Next Step. In this step, you will be determining how many host bits in the current subnet mask need to be borrowed in order to create the number of subnets determined in the previous step. First, you should write down the magic number you'll be looking for. The magic number is the number of subnets determined in the previous step plus 2. Next, open the subnet table, which is available by clicking on the link that reads Open Subnet Table. In the decimal values row, start from the right-hand column and look for the decimal value that is equal to or greater than your magic number. Once you find the column you're looking for, look up one row to the powers of 2 row and see what the exponent of 2 is for that column. That's the little number above the number 2. The exponent represents how many bits you'll need to borrow in the current subnet mask. Type the value of the exponent in the box in the upper right-hand corner. If the word correct appears in green, you've typed in the correct number. Now click on the Next Step button in the lower right-hand corner of the screen. If the word incorrect appears, you've typed in the wrong number. Try determining the magic number again, and make sure you're basing your answer on the number of segments you typed in the previous step. If you've forgotten that number, just count the number you now see on the screen. It's still the same number of segments shown in the last step. In this step, you will first need to type in the current subnet mask based on the prefix shown after the current network address at the top of the screen. Then, you will need to come up with a new subnet mask that will be used once your network is divided into subnetworks. In order to determine the current subnet mask, look at the prefix number, the number following the / at the top of the screen. The prefix number represents how many contiguous ones are in the current subnet mask. Remembering that a group of 8 ones represents the number 255 in decimal, the first thing you want to do is to type in 255 for each time that you can subtract 8 from the prefix number. For instance, in this example, our prefix number is 18. You can subtract 8 from 18 2 times. So type in 255 in the first octet and the second octet of the current subnet mask. Now, let's subtract our 2 8s, or 16, from the prefix number 18 and see what's left over. The answer, of course, is 2. So we need to represent 2 bits as a decimal value in the third octet of the current subnet mask. Again, the subnet mask table comes in handy for this purpose. Open the table by clicking on the link that reads Open Subnet Table, and then look for the row that has only 2 ones in it and see what the decimal value is. In this case, it's 192. That's the number we will type in the third octet of the current subnet mask. Now, since we have used up all the ones which were represented by our prefix number 18, the remaining bits will all be zeros to represent the host bits. You might remember from the subnetting table that the number 192 began with 2 ones followed by 6 zeros. In order to indicate that the rest of the bits are also zeros, just type in a 0 in the fourth octet of the current subnet mask. Now that we know what the current subnet mask is, we can type in our new subnet mask. Since our new subnet mask is based on the current subnet mask, we can type in 255 in both the first and second octet of the new subnet mask. Next, we need to add the number of bits we determined we needed to borrow in step 2. If you forgot how many that is, look closely at the instructions in the balloon in the center of the screen and you'll see it reminds us that we are borrowing 4 host bits in this example. That means in our new subnet mask, we need to add 4 ones to the host portion, which is where the zeros begin in the third octet. In our current subnet mask, the ones ended with the first 2 bits of the third octet, so we have 6 zeros left over in the third octet, and now we need to borrow 4 of those zeros and change them to ones in the third octet. So this means we'll take our original 2 bits, add 4 more borrowed bits for a total of 6 1 bits in the third octet. Now, let's look up the decimal value for 6 ones in the subnet table. Find the row which has exactly 6 ones in it, and you'll see the decimal equivalent is 252. So, we'll type 252 in the third octet for the new subnet mask. Again, when there are no more ones left, the bits are all zeros. So, we'll type a 0 in the last octet of the new subnet mask. If you've done this correctly, you should now see a green check to the right of both the current subnet mask and the new subnet mask. If this is the case, congratulations! Go ahead and click on the Next Step button. If you see a red circled check for either of your answers, then that answer is incorrect, and you need to rework your answer. Review this video again if you need to until both answers are correct and you see 2 green checks. In this step, you will take the current network address and break it into subnetworks by typing in the correct subnetwork address for each of the listed subnetworks. The key to this step is knowing the amount that each subnetwork jumps by. That is to say, what's the difference from one subnetwork to the next, which will be the same value between each subnetwork. To figure out the value of the jump between subnetworks, take the number 256 and subtract from it the decimal value greater than 1 in the octet that is farthest from the left in the new subnet mask. For example, say you have a subnet mask that is 255.254.0.0. In this case, you would subtract the 254 in the second octet from 256 because it's the octet that's furthest from the left, which is greater than 1. When you subtract 254 from 256, that leaves you with 2, and that's the amount your subnetworks will jump by. Let's take another example. A subnet mask of 255.255.224.0. In this case, you would subtract the 224 in the third octet from 256, which leaves you with 32 as the amount your subnetworks will jump by. Then, take your jump number and add it to the current network address to get the first subnetwork address. In our on-screen example, the current network address is 62.119.0.0, and our new subnet mask, the mask we're using to create the subnetworks with, is 255.255.252.0. We subtract the 252 in the third octet of the new subnet mask from 256, which leaves us with a jump value of 4. That means our first subnetwork, subnetwork A, will be 62.119.4.0. The next subnetwork, subnetwork B, will be 62.119.8.0. The next subnetwork, subnetwork C, will be 62.119.12.0. Notice that each jump between subnetworks is a value of 4. Fill in all of the subnetwork addresses using this methodology, and if you typed each subnetwork value incorrectly, you should see a green check appear to the right of each subnetwork address. When all of the subnetwork addresses display a green check, you've successfully completed the step and are ready to move on by clicking on the Next Step button. If any of the subnetworks display a circled red check, then the address you typed in is invalid, and you'll need to retype the correct address. If you need to, review this video one or more times until you can type in all of the subnetwork addresses correctly. In this last step of the subnetworking assessment, You will establish the IP address ranges for each of the subnetworks you're creating. One subnetwork at a time will be shown on the screen. You will be asked to type in the IP address for the first host, last host, and broadcast address of each subnetwork until you have entered the IP address ranges for all of your subnetworks. The IP address for the first host on each subnetwork will be 1 greater than the subnetwork address itself. For instance, if the subnetwork address is 192.168.0.0, the first host will be 192.168.0.1. It's a little tricky when the subnetwork address is contained in the fourth octet. For instance, if your subnetwork address is 192.168.16.32, then the first host address is 192.168.16.33. Notice the rule holds true. The first host address is always 1 greater than the subnetwork address. For our current on-screen example, subnetwork A's subnetwork address is 62.119.4.0, so its first host address is 62.119.4.1. The last host address of each subnetwork will be 1 less than the subnetwork's broadcast address, so it's easier if you figure out the broadcast address first. The broadcast address for each subnetwork will be 1 less than the next subnetwork's address. In our current example, subnetwork A is 62.119.4.0, and subnetwork B is 62.119.8.0. As we said, subnetwork A's broadcast address is 1 less than subnetwork B's address. That means that subnetwork A's broadcast address is 62.119.7.255, which is 1 less than subnetwork B's 62.119.8.0 address. Now that we know subnetwork A's broadcast address is 62.119.7.255, we can also calculate the last host address for subnetwork A, which is 1 less than its broadcast address, making the last host address 62.119.7.254. To calculate subnet B's broadcast address, subtract 1 from subnetwork C's address. Since subnetwork C's address is 62.119.12.0, then subnetwork B's broadcast address is 62.119.11.255, and subnetwork B's last host address is 1 less than its broadcast address, or 62.119.11.254. Once you complete typing in the first host, last host, and broadcast address for a subnetwork, a green check will appear to the right of each entry, and you'll be able to move on to the next subnet by clicking on the Next Subnet button. Continue completing the address ranges for all of your subnets, and you will have completed this step of the assessment. If you see a red circled check to the right of any of your entries, you must correct the entry before you can continue to the next subnet.